Hello, class. These are the video solutions to Lab 1.6. The purpose of this lab is to have us develop a linear regression equation and then use that equation to answer some questions. So we're given a table of Prozac prescriptions, right? The year is 1989. There were 6 million prescriptions, 91, there were 10 million, and so on. So if we want to enter this into our calculator, you don't use the years 1989 to 2006. We have to translate this to a base year. So this says the number of years since 1987. So 89 would be 2 years after 87. 91 would be 4 years after 87. 93 would be 6 years after 87, and so on. So we're going to enter this information into our calculator. So I pull out my calculator. I press the STAT key. Actually, before I do that, I want to make sure all of our calculators look the same. So if you press the mode key, scroll down. Now, some of you will have this Stat Wizards. If you have an old calculator, you will not have Stat Wizards, and you don't have to do anything, okay? So the keystroke I'm about to do is only for people with the new calculator or a newer calculator. So when you press the mode key and scroll down, if you see Stat Wizards, I'd like you to highlight off. Okay, so right now mine is on. I want you to highlight off and press enter, and then all of our calculators will look the same. Okay, again, if you have the older version, you don't have to do anything because you don't have this feature. The newer calculators, we're going to put Stat Wizards to off, and then we can press the STAT key. I can press enter. And in L1, I'm going to enter this information, the 2, the 4, the 6, 14, the 19. In L2, I'm going to enter the 6.1, the 10, the 12.1, and so on, right? So here's my L1 and my L2 data. It's coming from these two areas, okay? Next, I want to press Y equals. And you see how my plot 1 is off? I want to press the up arrow and press enter. And now my plots are on. Okay. Another way to turn your plots on would be to press the second and the Y equals key. And you see how it says plots are on, off, off. You can press enter in here and toggle between on and off. Okay. But I think it's just quicker to press the Y equals and then just go up and down, right? Enter. My plots are off. Go up. Press enter, my plots are now on. Once your plots are on, if you press the zoom key and number 9 for stat plot, there we go. All right, so this, I think this matches what we've done by hand here, right? Notice there's 3 dots. I have 3 dots. Here's 2 dots. If I can move my calculator, you'll see 2 dots. So, and then notice it says pay attention to the labels, right? The x-axis is years since 87. The y-axis is the number of prescriptions in millions, okay? The next question has us actually develop the linear regression equation, okay? So now that we have our scatter plot, if you press y equals, make sure there's nothing in here, okay? And now press the STAT key, press the right arrow to highlight calc, number 4 for linear regression. We want L1, so press second 1, that's L1, comma, second 2, that's L2, right? Notice above 1 it says L1, above 2 it says L2, and then the comma is above the number 7 key. And then the last thing we need to do is Y variables. So press bars, highlight Y variables. It's a function, so press 1, Y1, press 1. And you should have something that looks like this on your screen. 2 commas, right? L1, comma, L2, comma, Y1. I press enter. And these are the components to my regression equation. Now, on a test, you wouldn't write A is this and B is that. I want the equation, right? Y equals mx plus b. And it looks like they replace Y with P and X with T. And then they wrote the 0.8269 and the 5.9777, etc. Right, so there's my regression equation. This will be the last question on test 1. I'm definitely going to ask you to do this. So make sure you can develop this equation. Question 4. Use the equation, table, or graph to estimate the number of prescriptions in 2000. Well, remember, 2000 is 13 years after 87, so T would be 13. So for number 4, simply plug in 13 to T and solve, and you end up with 16.7 million prescriptions. You could also press second and window. See above window it says table set. I'm going to start my table at 0, and I want to count by 1. And above graph it says table. So if I press second graph, here's a table, and if I scroll down to x equals 13, right, when x is 13, y is 16.728, right? So 13 years after 1987, I have 16.7 million prescriptions, which is the same answer we found by simply plugging 13 in for T. Right. Number 5, it says, all right, now how many prescriptions were in 2008? Well, 2008 is 21 years after 1987. I could simply scroll down to 21. And there it is. Oops, I went too far, right? I could put 21 into my equation and I'd get 23.34, right? So if I put 21 into T, I should get 23.34, right? That's using the table. You can also graph it. Now, notice we're going out to 21. So if I look at my viewing window, press window, my calculator stops at 20. So I need to increase that to, say, 25, press graph. And now if I press the trace key, I see how it says plot 1, L1, L2. That's not what we want. That's the dots. We want the line. So I press the up arrow, and now I have my equation, right? 0.8269 x plus 5.977, right? Doesn't that look familiar? That's our equation. Okay, so now that I am on the line, press trace and press, I think it was 21. Oops. Let me bring that graph back. I press trace. Here's my line. I press 21. So it says when x is 21, y is 23.34, right? So I was able to get this 23.34 several ways, okay? And it just says the equation, the table, or the graph. So just pick one of the methods and give me the point. Number 6, which is more reliable? Well, in number 4, our T was 13. In number 5, our T was 21. So 13 is in between our 2 and 19, right? 21 was past 19, right? So for the answer in question 4, this is an example of interpolation, right? Because 13 is in between our given data, right? Or if we look at the other table, the year 2000 is in between 1989 and 2006. So interpolation is always more accurate than extrapolation, right? 2008 is outside of our given data, an example of extrapolation, right? Or 21 is outside of 2 and 19. So the further we get away from our data, the less reliable. So for number 6, you'd say, I have more faith in the data from question number 4. Number 7, and the final question, use the regression equation table to estimate when the number of Prozac prescriptions exceeded 25 million. So if we use the table, oops, I pressed the wrong button. If I press second and table, which is above graph, you want to see when does y, right? Y represents the number of Prozac prescriptions, and x was the number of years after 87. So you can see we're at 20 million prescriptions, 21, 22. When do we get to 25 million? So it looks like 24 years maybe, right? Somewhere between 23 and 24 years would be my answer. Looks like 23.004. So if you told me 2010 or 2011, I would accept either of those answers. All right, so this was the table method. You could also just plug in 25 for y, right? Remember, y represents the number of Prozac prescriptions, or P, and T is the time after 1987. So if I know the number is 25, I can replace the p or the y with 25 and solve for t, number of years after 87, and you end up with 23.0044. Okay, so that's another way to solve this problem. Thank you for watching. If you have any questions, please send me an email, come to office hours, or even come to my lecture on Tuesdays.